good morning, my dear students. In today's class, I'll be explaining more about the HCF and we'll try to solve some board problems also. So, what is HCF? Highest common factor. Now, listen to me. This highest common factor can be determined by various methods. Please take down. One is division method. Let me consider 100 and 190. So by division method you can do it. How? This is division method. For example, 190, you have to take the biggest number and divide this by the smaller one. So 100. Okay?
9.
One time 100, then 90, and you have to bring the divisor inside as dividend. Okay? How many times? One time. So 90. Then 10. Now bring the divisor as a dividend. So 90. So it means 9 times. So 90. 0. When the remainder is equal to 0, that particular divisor is declared as HCF. Do you understand this? So in that case, a 10 is the what? HCF. So you can declare 10 is the HCF. Is it clear? So this is one method. Then second method. Here you have factorization technique. This is a simultaneous factorization. Okay. So simultaneous, take down, simultaneous factorization method. How you can do? You can take 190 and 100. Okay, right? So start from the smallest prime number always. So what is the smallest prime number? 2. So how many times? 9 2s are 18, balance to 5 times. This one is 50. Okay. Now this is not divisible by
5. 2.
2.
But divisible by 5.
But divisible by 5. So let us consider 5.
19.
So
10.
1 9 and this is 10. You can further divide this by 5. So 5
19.
and 19 will not go, so you can retain the 19 as such. And then what about this? 2. Now all are prime numbers. So once you are able to get the prime numbers, okay, now which is the common one here? The common one is 5 and 2 only. Okay, in both the cases. So 5 and 2. Okay, so the 19 and 9, that is not common because it is different, you know. Okay, you have to consider only the common factor because highest common factor. Okay, so in that case you can take only this. So 5 into 2, 10. So you can declare 5 into 2, 10. If there is no common factor, in fact you can stop it. You need not go further. Okay. Then, and what about the other method, normal factorization? 3. So take 100. What is that? It can be written as 100 factorize 2. This is 50. 2. 25. 5 means 2 squared into 5 squared. and consider the 190, another number 190. Okay, so divide this by 2. How much? 90.
95.
9 2s are 18. 5, and again
5.
5,
19.
then 19. So you can take 190 is equal to, is a composite number of 2 into 5 into 19. Okay, so you have to consider the that is lowest power of the common term. Do you understand? Take the lowest power of common term. Okay, so in that case the common term is 2 and 5, and among 2 squared and 2, which is lowest power? This 2, so you can declare 2. 5 squared and 5, which is the lowest power? 5, so into 5, that is equal to 10. You can declare this as HCF. Okay, you understand this, right? There is another technique, that is, you can make use of this one also. For example, HCF into LCM is equal to the product of this number, given numbers, that is A into B. You can consider this A and B. Are you able to follow? Now we are interested to find out what? HCF. A is known, B is known. Sometimes they will give LCM. Otherwise you can find out LCM also. Okay. How to find out LCM? Let us adopt this method, common factorization technique. That is, find out LCM of 190, 100. Okay, so 2, 95, 50. Again 5, 19, 25. So in the case of HCF, you can stop with this because there is no common factor. But in case of LCM, you can further continue. So how? You have to divide by this, and this is retain, and this is 5 times. Okay, now all are prime numbers. You can multiply everything. Do you understand this? So multiply everything. That is 5 2s are 10.
Sir. 5 into 10, 50.
5 into
10.
sorry, 5, 10. So in that case 2, right? So 2 into 19, 38. 38 into you can put like this, 2 into 5 into 5 into 19 into 2. Do you understand? So 19 into 2, 38. 2 into 5,
10.
how much?
10.
10. 10 into 5, 50. So multiply again, 0, 5 8s are 40, balance 1, 5 3s are 15 plus 4, 19. So 1900 is the LCM. Do you understand? What is that? 1900, that is LCM. The same LCM can also be found out by, this is simultaneous factorization and individual factorization also. How? 190. Take the factors. 1,
5 into 2 into 10.
yeah, that is 190. So 2, 9 2s are 18, 5 2s are 10, and this is 5. It means 19. So you can take 2 into 5 into 19. What about 100? For 100, 2, 50, 2, 25, 5, 5. So 2 squared and 5 squared. Okay. Now in the case of LCM, what you are supposed to do? Take the highest, okay, highest common factor. So which is the highest common factor? Now you have got the 2 squared. Okay, you can take this 2 squared. and 5 squared. So you have to consider the highest one, and the remaining should also be taken. So 19 into 19. Do you understand? Now you will get 1900. So LCM is 1900. Now let us come here. So we have found out LCM. Okay, you can make use of this. Therefore HCF is equal to, what is A? 100 into 190 and divided by LCM. Is it not so? 1900. Got it? Now 0 0 0 0 19 19 can be cancelled. The remaining is 10. So this is another technique. Sometimes they will give the LCM also. You may be asked to find out HCF. And similarly you can find out LCM based on HCF also. Okay. So HCF here, in this case we can find out the LCM. So this is first method, second method. Third method is you can make use of this equation. Okay. That is HCF into LCM is equal to A into B. We are interested to find out LCM. Therefore A into B divided by HCF. Do you understand? Now LCM is equal to, what is A? 190 or 100 into 190 divided by, now what is the HCF? 10. So this is another easiest method to find out LCM. So 0 0 cancel. So 1900. Okay. Got this? Right? Okay. Now, how this LCM and GCD are going to be useful for you in other sums, other arithmetic problems. Now, let us consider. Sometimes you will get problems like this. 35A plus, and here 15, okay, what is that? B, let us say, right? Now in order to take the common term outside the bracket, we can make use of this. So this HCF can also be called greatest common divisor also, GCD. Please note down. Now in that case we have 35 and 15. We had to take the HCF for this. Okay. So let us adopt the division method. 15 2 times 30, balance 5, and here 15 3 times 15 0. So this is the remainder, and definitely this is the HCF or GCD. Now you can take, are you listening? Now you can take the 5 outside the bracket. So when you take outside the bracket means what? You are dividing this. Okay. So 5 is the GCD. Okay. You are dividing 35 divided by 5A plus 15 divided by 5B. Do you understand this? And that is why we put, that is 7A plus here 3B. I hope now you should be able to understand the need for HCF. For taking the common term outside the bracket, we can make use of this. Okay, right. Now, what about LCM? So this is the case of GCD. The LCM is going to be useful for you for adding and subtracting fractions. For example, let us take the same term, that is say that is 3 by 35 minus 15 by you can put 45 by 15 or 42 by 15. Okay, let us take like this, 42 by 15. So what is the answer? What you can do, you have to take the LCM. How to take the LCM? 35, 15. Take the LCM, 5, 7, 3. Okay, so in that case what you are supposed to do, you have to multiply all the factors here. Nothing is repeated. So 5 into 7 into 3. So it means it is the least common multiple. So 5 into 7 into 3. So that is equal to 5 into 7 3 is a 21. So 5 into 21, 105. So the LCM is 105. You have to take 105 as a LCM. Now you should be able to get 105 from this denominators. Okay, what you can do, now listen to me carefully. 105 divided by 35. Okay, how many times it will go?
3.
3 times. Okay, so 105 divided by 3, so 0. So 3 is the multiple here. So you can multiply by 3 and divide by 3. So 35 into 3. Do you understand? And 42 divided by 15. So 15 you have to consider. So 105, 15. How many times it will go?
7, 7.
7 times. Okay, so 105. In that case you should be multiplied by 7, and the denominator should also be multiplied by 7, and thereby you are able to get 3 3s are 9 by 105 minus, what about this, 7 2s are 14, balance 1, 7 4s are 28, 29 divided by 105. Since 105 is a common denominator, you can make it as a single term 105. Now subtract.
9 minus 2.
Okay, 9 minus 294. So 294 minus, so
9.
9, 8, and this one 2. 9, okay, 9 means 5. So 285, right? So you can declare minus 285 divided by how much? 105. Okay, so this is the way you have to proceed. Do you understand? I hope now you should know the importance of this LCM and GCD. And you should learn another important one. How to convert or check the ration numbers. How to represent the ration number? P by Q, where Q is not equal to 0. And these P and Q are called co-primes. Okay, take down. Now let us have, it should be in the form of, that is particularly this Q should be in the form of 2 power n into 5 power m. So you have to convert in this way. Now if it is in this form, let us say yes, means you will have decimal expansion. Take down decimal expansion. So decimal expansion, it is terminating. So when it is terminating means it should be a ration number. Okay, now let me give you an example. For example, let me take 1 by 2. So we have to convert this into this form. In order to convert this into this form, what you can do, you can take this 1 by 2, multiply and divide by 5, right? So that you are able to get 5 divided by 10. Is it not? So 5 divided by 10 means that is 0.5. So you can convert the fraction, and if it is a rational number, you can have a terminating decimal expansion like this. Okay, and why it is why 1 by 2 is a rational number? Because it is in the form of, it can be written in the form of 2 power n into 5 power m. Okay, so we are able to write this. For example, 5 divided by 2 into 5, it means 2 power 1, 5 power 1. So it is declared as a rational number with decimal expansion. Okay, right. Now let us consider the other one. Say this is not convertible. For example, no, let us say. So let us check the decimal expansion. Decimal expansion checking. So here it is non-terminating. Non-terminating. It will go. Okay, and also it is repeating. If it is a repeating, okay, then it is a rational number, but it is not in 2 power n into 5 power m form. How? Let us take 1 by 3. Okay, so 1 by 3, it becomes 0.333 etc. It means 0.3 bar, because this cannot be converted in this way. Okay, so we can declare that 1 by 3 is non-terminating but recurring rational number. Are you able to follow? Right. So try to understand this. And next one. Let us discuss another sum. Take down. If the HCF of 152 and 272 is expressible in the form 272 into 8 plus 152x, then what is x, or find x. Okay, now see, that is 152 and into 8, is it not? So you can take like this. You know very well, a q plus b is equal to r, the remainder. Are you able to follow? So if it is a remainder, now we have to target on the remainder. Okay, so what is the remainder here? Let us consider 272. Follow this, 272. Okay, so this 272, you have to take there are two numbers, you have to consider the bigger number and take this as dividend, and you have 152. Let us find out HCF. What is that?
1 time.
1 time. This one, how many times? 152 only.
1 2
So 0, 17 minus 8, how much? 7 by minus 5, 2.
1
This one,
1
1. So 120, 152.
1 time.
Okay, how many times?
One
1 time. So 120,
30.
that is 2, and this is 32. Again 32, 120 should be taken inside, and 32. How much? 3 times 6, then
3 times
9,
96.
and 4 here, how much? 11 minus 9, 2,
2.
so 32. Bring it here. What is that?
1 time.
Huh?
1 time.
1 time, so 24.
8.
What is that?
Eight.
8. Okay, so you know very well 8 and here
24.
24. So 3 times, and what is that? 24. 0. When the remainder is 0, the HCF is how much?
8.
8. So this is the HCF. So what is given here? If the HCF of 152,002 expressible in the form of, now we have found out the HCF. Okay, so 272 into 8 plus 152x is equal to, okay, this 8. Do you understand this? Okay, now this 152x, you can take this as a whole, is equal to, what is that? 8 minus 272 into 8. Do you understand? Okay, now you have 8 is common, you can take outside the bracket, and 1 minus 272, right? Okay, so that is equal to 8 into how much?
2 1 sounds.
Minus 271. Okay, so now you have 152x. Got it? Therefore x is equal to 8 into minus 271 divided by 152. Okay, so this goes 19 times. Are you able to follow? Therefore you can declare this as x is equal to minus 271 divided by 90. So this is another tricky problem. This has been asked in one of the board examinations. Okay. Is it clear? Shall we go to next sum? Have you noted down? Can anyone try this sum? Take down. Find out the HCF. Go and write on the board. Find out the HCF of 135, 225. You can adopt all those methods, whatever I taught you.
So we want to find only HCF only, sir.
Only HCF. You can also find LCM, but find out HCF first. You can apply all the 4 techniques. You can put one division method.
Other?
No, you have to proceed. I will teach you. Now remember, just refer this. What is the problem for you?
Since
Where you have gone wrong?
sir, I put minus back.
Why minus? One time you have to take the bigger number. Bigger number is 224. Now listen. So division method. Division lemma. 224. Listen to me. 135. How many times it will go? One time. Now 14 minus 5, 9. 11 minus 3, 8. Proceed. Again 135. Proceed. There is a problem for you to subtract. What are you doing? 135, 89, again 135. Proceed one time. Now you try this double bracket like this.
Sir,
You have to take the bracket like this. Don't take.
46, 49.
See, listen. Don't put the line. See that if it is a division, normally you do about 224. You will put the quotient like this. Is it not?
yes, sir.
So one time 135. But in this technique, you have to put the bracket like this. This is the dividend. Okay.
Yes, sir.
And here you have to put the quotient, and here you have to put the divisor. You understand? Likewise here, don't put this method. Okay. So 89, 130. Don't put here. Put the bracket here. So one time 89 and 6, and this one 12 minus 8, 4. Now bring the previous divisor. So 40, 89. One time. So 46, 3, 43. Again 46. Okay. So one time. 43, 3. Okay. 43. Again. How many times? 43. So 3.
15.
1 and this is 13 3s are 39. Is it not? Okay.
42 vrum, sir.
42 14. Okay. So 42. Balance 1 and put 3. So 3 times 3, that is 0. So the remainder is 0. Therefore the HCF is 1. Do you understand? So likewise you have to go.
Yes, sir.
So in fact, in this case, there is no common factor at all. 1 alone is a common factor. Do you understand? Right. And now let us try another example. Take down. You can erase that. Now if you want to get an GCD for this, you want to make it as a common factor, you have got already 1. By adding 1 to this, you will get some HCF. Shall we try? Try 135 and 225. 135, 225. Try. Find out the HCF and LCM both.
Sir, by any method, sir.
Division method. Let us apply Euclid's division lemma. Okay. What is the basis of Euclid's division lemma? Can you tell me? A is equal to Euclid's division lemma. A is equal to BQ plus R. Where R is equal to or less than A, 0, and that is less than B. When, listen to me, when R is equal to 0, B is the HCF. That is another way. This is another technique. When R is equal to 0, B is the HCF. That is why we declare B as HCF.
Okay, sir.
Do you understand this?
Yes, sir.
Proceed. Okay, I'll teach you. Now listen to me. We'll go by 225. Take this 135. How many times?
1 time.
Huh?
110.
225.
110.
One time. So 135. Subtract 0.
90.
This one 90. Again 135. How many times?
1 time.
Again one time. So 90. Now
40.
45. Now put 90
2 times.
2 times 90. That is equal to 0. So this is R. Therefore this should be the what? HCF. Now I will apply this technique. Okay, listen to me carefully. Let me go like this. What is A here? A is a smaller, bigger number. So now listen to me carefully. 135, 225. Okay. So here you can write this as 225 first, followed by 135. So always bigger number first, and that should be considered as A here. This is B. Do you understand? So A should always be greater than B. It means A is the what? Dividend. Okay, A is the dividend, B is the divisor. Take down. A is dividend. It is the number to be divided. For example, I have got 100 rupees. See, listen, I have got 100 rupees. Listen, I want to distribute to 10 students,
Each 10.
each 10. So in that case, this is called dividend. I hope now you should be able to understand what dividend means. Okay, and this is divisor. What is that?
Device.
Divisor. Divisor. And the result is 10. That is called quotient. Okay, this is quotient. Now based on that, A is equal to dividend, B is equal to what?
Divisor.
Divisor. And what about Q? That is quotient. Take down. Quotient. R is equal to 0. In this case, remainder. Don't put MIND, MAIND or remainder, not reminder, remainder. Now listen to me. The logic here is, take down, A is equal to B into Q plus R. This is the Euclid's division lemma. Now listen to me carefully. When R is equal to 0, B is declared as HCF. So this you must remember, and that is why I have taken B, the particular divisor, that is the divisor for which the remainder is equal to 0 is declared as HCF according to Euclid's division lemma. Okay, can you repeat? What is that? You can write down. What is HCF? HCF is the divisor when the remainder becomes a 0. Okay, so that is the logic, and based on that we are going to proceed. We have got already this one 225, so we will do one by one. So A is equal to BQ. So what is A here? 225 is equal to 135, correct, into 1. Okay, 135 into 1 plus 90. This is the first stage. You please check it up. Are you able to get 225? Okay. What I told you, you have to take the 135 as the dividend. So dividend. Now, and 90 should be taken as the divisor. Okay. And for which, what is the quotient? You have to find out the quotient. That quotient is 2. And what was the remainder? The remainder was 45, correct?
Yes, sir.
And again, that is bring the
Sir, 90 into 1, not 2.
90 into 1. And again, you have to consider this B. So bring this B here, 90. Okay. And bring this 45 here. That was a remainder. Take inside. So 45. Now what is the quotient? 90 divided by 45
2.
into 2. So in that case 90 minus 90, 0. Is it not? Now you can declare 45 as a HCF. Now B is 45. It means HCF is 45. So do you understand this technique?
Yes, sir.
Okay? Right. So we will proceed in the next class. You have to practice a lot.